Hi, Ian Zepp here. Gauntlet Week 2. This is the weekend summary. This is going to be more of a presentation than a demo, so please bear with me. It also might be a little bit longer than the requested 5 minutes. Here is the rough timeline. I'm not going to go through this in too much detail. Monday is assigned, 24 hours later, MVP is due. Most of my functionality was finished on Tuesday, so on Wednesday I pivoted to a new approach. Most of that functionality was finished by Friday. So on Friday I did a side quest, which was to rebuild Ghostfolio in Go. And then today is Sunday for delivery. Within the first 24 hours, the MVP, within the first 2 or 3 hours, there was a telnet implementation to the LLM built-in Ghostfolio. The browser came shortly thereafter. And then within about 12 hours, there was a terminal TUI that talked to the LLM. Basic evals and the railway deployment took up the rest of the first 24 hours. This is what the initial inside the browser UI looked like for Ghostfolio. It's very straightforward. Chatbot, text in the center, bold tables converted from Markdown, some basic information on the right-hand side, and an input at the bottom. Now, to note, this was embedded into the application itself, which was a technique, an approach that didn't last very long. Here is the initial CLI tool that accompanied the MVP. This was modeled after Bloomberg colors, Bloomberg terminal colors. A little bit basic, not fully fleshed out yet, and it didn't last for long because shortly after we converted it into a Rust interface. So starting in Wednesday, I decided to strip out the LLM from inside the Ghostfolio server, and I moved it to a React loop in a Rust CLI and TUI tool directly. This allowed me to minimize the upstream impact of having to try and merge my agent into Ghostfolio code if that's what was wanted, because now the TUI could just run directly inside of the tool itself, the LLM could run inside the tool itself, and it didn't need to have any changes in Ghostfolio. Also with the TUI, I included all of the evals frameworks, which we'll show here shortly. So this is the revised TUI interface. It looks very similar colors with some additional items on the right. We can see a different status bar down here that's showing some stats of things. And the testing framework was run also as part of Rust, and this is done using parallel keys with multi-leases per key. I'll explain that a little bit more in detail later. Essentially, you have multiple connections to a single API key. So that allows all of these tests to run in parallel, and the more you scale out your API keys, the faster your tests go. The eval framework itself, 3-tier. Primary tier was, did the agent call the right tools when you asked them the question? So which of my holdings performed best this year? These are the tools we expected them to call. And then, based on what they called and they returned a response, did they return expected values? Did they return things they weren't supposed to? And did the tool results have certain values in them? So that's all tier B content validation. And then tier C is having an extra layer that verifies whether the data that they returned actually makes sense or not. One minor note, there are 214 test cases in my evals framework, which is significantly in excess of the 50 required for the project completion. The parallel execution for the API keys runs like this. We queue up all of the cases, and then for each key that we have recorded, in this case I'm using open router keys, so I had multiple open router keys with multiple leases per key, we start assigning LLM conversations to leases. As they finished, they're pushed off into the grading system, and the grading system then evaluates whether the various tiers passed, and the entire run is saved into both a JSON file as well as into a database, an SQLite database, so that we can do summarization and reporting based on that. So Friday night rolls around, and much of the evals was done, mostly working, and I decided that it might be fun to just rewrite Ghostfolio itself with the 48 hours that we had left until final submission. So, starting at 4:16 p.m., everybody seemed to be on board with this. And by 10 a.m. Saturday morning, I had largely completed a rewrite of Ghostfolio into Go. Now, the original stack, as it says here, was Angular, Nest.js, Prisma, Postgres. I sliced out the back-end portion first and converted it to Go. I used a development loop where I essentially had Claude execute part of the plan. And then once Claude was done doing his thing, I had Codex come in and fix all of the bugs that Claude had not implemented properly. And once the implementation was supposedly done, we looped over red-green tests where we matched up what the legacy server was returning for the API with what the new Go server was returning. And we fixed Go until the two matched perfectly, both in terms of the HTTP status as well as the JSON response format and data. Because both Nest.js and Go were talking to the same underlying database, we could be confident that if there was any difference in the response, it was because Go wasn't behaving properly. And then finally, once that was done, we went back to Claude, showed Claude the changes, and said, what are we going to work on next? Now, the red-green loop was great because it allows us to have really good confidence that the new back-end server was properly matching the format. Whether it was bug-free or not, that wasn't the question. The question was, did it behave and return data exactly the same as the legacy did? So this is a common situation where you have an infrastructure that's written in an older language and you want to bring it into a new language for maintainability purposes or something else. You need confidence that the new implementation behaves the same as the old so that other parts of the system don't break. And that's what this red-green testing loop allowed us to do. The red-green loop was the inner loop, and then the cycle of Claude to Codex and back to Claude again was the outer loop. And what those two together allowed me to do was extend the working context of Claude and Codex across an 8-hour period. So there was a comment in Slack when I brought this up that I thought was really interesting, so I want to call it out here. Most developers, when they start using LLMs, they're in Cursor, and so they're focused on a function or they're focused on some refactoring line of code, restructuring something, and they're thinking in terms of tasks. When they start moving into Claude code in a terminal, they stop necessarily thinking about, I need to change this function or this line, and they start thinking about, I have this problem that needs to be solved. And so it becomes can I fix this problem within the context window that Claude allows me or Codex allows me? But when you start looping between LLMs and saving the progress with tests and with readmes in between, you stop thinking about context windows and you start thinking about overall project knowledge continuation. So each time we're jumping from one loop to another, we're losing all of the formal context, but we maintain the test structure, we maintain the knowledge and the readmes in between. Claude Memory works for this as well. Other sorts of memory database structures work as well. But the whole point is that you're moving from task to context to project perspective in how you're treating the LLM. So seams and contracts. I think I talked about this briefly before. The contract with the REST API allowed us to swap out the Prisma server into a GoFolio server because we had confidence that GoFolio, through the red-green testing, was providing the exact same API contract. So we could run GoFolio with Angular on top, the legacy client, and nothing would break because Angular was just making API calls. And underneath the GoFolio API, we were using the exact same table structure to the exact same Redis and Postgres databases. And so nothing was changing there as well. You could swap these with effectively no impact to either the upper or lower layers. Same structure for swapping the UI side out. So this is just the inverse. Now, because of the API contract, we can go from the old Angular interface to a new SvelteKit and Tailwind interface. Both of them are talking to the same API contract, and we can use either Ghostfolio or GoFolio API in the background. And that's exactly how I have it set up on Railway. So on Railway, I have the new web app connected to the old Ghostfolio. I have the new web app connected to the new GoFolio API, and I have both GoFolio and Ghostfolio talking to the same underlying Redis and Postgres underlying databases. Finally, moving on to stats and stuff, we had a significant number of commits, 469 over 7 days, which is 67 a day. That's not terrible. There were a lot of commits in Ghostfolio, but many of these ended up moving to the other 3 repos that were created. API had ending with about 25,000 lines. Web was 13,000, and the CLI tool was 24,000. The interesting thing to me here in all of this is our 70% survival rate. So we kept roughly 70 lines out of every 100 that were generated, which is not terrible when we're iterating through so many unknowns to start with. It kind of means that the work that you're building out tends to be structurally acceptable enough that you keep it even as you're pivoting and restructuring the architecture. And then finally, there's an interesting distribution of languages. Svelte and TypeScript, similar. YAML for the test cases, Rust for the CLI, and Go for the new backend server. These are the links. I'm not going to go through them in detail because we're already quite long into this video, but they are available. They're up in production. You can try them out. And then the open source repositories for the new implementations are here. And that's it. Thank you.